So solvable group number 4 for trigonometric integrals, powers of cotangents, and cosecants. Basically, we have similar methods now with group number 3. So we just replace tangent with cotangent and secant with cosecant. So the three cases, okay, for group 3 are applicable here. So case 1, if the cosecant's power is positive even integer greater than 2. So factor out cosecant squared u du, then change the remaining cosecant into cotangent of function using the Pythagorean identity. So for example, case we have sine x at the denominator. So if we let sine x be our u, so there's no other function that will form the du. So meaning we cannot directly use the substitution formulas of integration. Okay, so we use case number 1 here. So we first write it in the form cosecant x. Okay, this is the reciprocal of cosecant. No, sine is the reciprocal of cosecant. So we can write it as cosecant of x. No, raised to the power of 8 dx. So the exponent of cosecant is an even integer greater than 2. So we factor out cosecant squared. So what will remain is cosecant raised from 6. Okay, and then the cosecant here for the du later. Then transform this into cotangent using this Pythagorean identity. Okay, but this is still in the power of 6. So that's um cosecant squared and then quantity raised to the power of 3, right? So cosecant squared is 1 plus cotangent squared. So raise this to the power of 3. So again, this is equal to cosecant squared, then raise it to the power of 3. So it's just the same as you raise cosecant to the power of 6. And then ready for the du later. So we expand the binomial. So 1 cube. So recall na buntag special product formulas. If we have u plus v quantity cube, so that's u cubed plus 3 u squared v plus 3 u v squared, then plus v cubed. So the cube of the first term, so 1 cube is 1 plus 3 times 1 squared times cotangent squared. So 3 cotangent squared. Then plus 3 times 1 times the square of the second term. So that's 3 cotangent of x raised to the power of 4. Then the last term would be the square or the cube rather of cotangent squared. So that's cotangent of x raised to the power of 6. Okay. So the last three terms are in the form cotangent x. So we can let u be equal to cotangent x. And then we'll have the du here. Okay, but the first term does not contain cosecant or rather cotangent. Okay, so we cannot write it in the form u raised to the power of n. So we'll just write the first term separately, multiplying it to the cosecant squared. Okay, x. So cosecant squared x dx, we have an integration formula for that. And then just proceed with the other three terms. So they are similar because they contain cotangent. So we can write them in the form u to the power of n. Okay, where u is cotangent x. So the cosecant squared will form the du, because cotangent u or x, derivative is negative cosecant squared x dx. So we can write these in the form u squared, u raised to the power of 4, and u raised to the power of 6 respectively. To proceed to integration, the integral of this is negative, cotangent x plus c. Then plus, we have 3. Integral of u squared is, okay, so we need a neutralizing factor, di. So, careful with that. No, we need a negative sign, therefore neutralizing factor is -1. So we'll just write it here. And then quantity. So the neutralizing factor is for the 3 terms. Okay, so make sure to enclose with grouping symbol. Then proceed to integration. So it's 3u squared, or integral is 3u cubed, no, over 3. Then plus 3u raised to 5 over 5. Then plus u raised to 7, no, over 7. And then plus c. So negative cotangent x minus, this is 1. And then u is cotangent x. So cotangent x is power of 3. Then minus 3/5 cotangent x raised to 5. Then minus 1 over 7 cotangent of x raised to 7. And then plus c. So this is the answer for integral of dx over sine of x raised to 8. So case 2 is if m is a positive odd integer. So we factor out cosecant u cotangent u du, then change the remaining cotangent function to cosecant function using this Pythagorean identity, so that you can express it as sum of powers of cosecant u and then cosecant u cotangent u du. So for example, okay, cotangent here is having a positive odd integer exponent. Okay, so, and there's a raised to the power of 5 here, but it's being raised to a power of what do you call this? 1/2, no? So we can write this as cosecant, but it's 5 times 1/2, so that's 5/2, or that's 2 and 1/2. So meaning, okay, or we'll just write it in using rational exponents para mas easy to work on. Okay, so it's cosecant 5/2. Okay, dy. So we factor out cotangent, cosecant. So if we remove one cotangent, so it's now cotangent squared. And then 5/2, so that's 2.5. If you subtract 1, that's 1.5 or 3/2. So we have na lang 3/2 here. And then the ones that you are factoring out. Okay, then the cotangent, or rather the cosecant. Or the du later. Okay, so we need to express the remaining cotangent as a function of cosecant. So using the Pythagorean identity, okay, so this is cosecant squared minus 1. And then multiply it with the remaining cosecant here. And then this would form the du later. Right, and then multiply to cosecant raised to 3/2. So it's cosecant, we have 2 plus 3/2. So that's 3.5 or 7/2 minus cosecant. So let me write the fraction this way lang para lesser space. And then again, this would be our du. All right, so we let u be equal to cosecant 3 halves y, so that we can transform it to u raised to the power of 7 halves later, and then u raised to the power of 3 halves. So if this is our u, then du is negative cosecant, no, 3 halves, cotangent 3 halves, dy, and don't forget the derivative of 3 halves y, or 3 halves. Okay, so this entire thing would be multiplied by 3 halves. We'll just put the negative sign there and then the 3 halves here. So we need a neutralizing factor, the reciprocal of this, which is negative 2/3. So if we do that, we can transform it into u raised to the power of 7 halves minus u raised to the power of 3 halves, because we have already our du. All right, so integrate using power formula. So it's u raised to the power of 7 halves plus 1, that's 9 halves. So over 9 halves minus u raised to the power of 5 halves over 5 halves, and then plus c. So it's negative 2/3 times 2 over 9. So that's negative 4 over 27. So you plug in cosecant 3 halves y. So it's cosecant 3 halves y raised to the power of 9 halves. And then we have plus 2/3 times 2 over 5. So that's 4 over 15. And then cosecant 3 halves y raised to the power of 5 halves plus c. So this is the integral of cotangent cube 3 halves y and square root of, does that cosecant raised to the power of 5? Cosecant raised to the power of 5. Okay, dy. So case 3 is if m, or the exponent of cotangent, is a positive integer, whether odd or even, and the integrand is cotangent only. So we factor out cotangent squared u du, then change that cotangent squared u into cosecant squared u by using this Pythagorean identity, and repeat until all integrands are already solvable. So we have cotangent cube. So there is no other function. So we need to factor out squared. So what will remain is cotangent z na lang. Then the cotangent squared here. Then express this as cosecant squared z minus 1. All right, and then multiply cotangent z and cosecant squared z, then minus cotangent z dz. So we can easily integrate this. Now we have a formula from I4 to I15, and this one is also using those formulas, and we let u be equal to cotangent. So for this first term, let u be equal to cotangent of z, because our du is negative, no? Cosecant squared z dz. So we need a negative 1 as our neutralizing factor. And then for this second term, so just integrate. So we have negative. So this is now in the form u du. Okay. So let me write it down. So cotangent z is the u, and then the cosecant squared will be part of the du. So it's u du. And then second term, let me write lang sa without integrating yet. So this is using our formulas. It's negative u squared no, over 2. And then minus integral of cotangent z is ln of sine z or negative ln of cosecant z minus negative ln of cosecant z. Okay, then forget the plus c. So we'll use or we'll put another answer. Okay, or we write it to the right of this first one. So we can write it as negative u squared over 2, then it's minus negative no ln of cosecant z plus c. So we replace u with cotangent z. That's negative 1/2 cotangent z no squared, then minus ln of sine z. Sine z plus c, or negative 1/2 cotangent squared z, then plus natural log of cosecant z plus c. So this is the integral of cotangent cube z dz. Okay, so these are the 3 cases for group number 4, or powers of cotangents and cosecants.